Hello everybody and welcome to video 6 in this tutorial series where I'll be showing you how to deploy our Cartesi decentralized application. Now before I get into all of the steps, I just wanted to show you this site here, which is called Rollup Lab. The URL is rolluplab.io. It's powered by Cartesi and it showcases a bunch of interesting projects that have been built using Cartesi's framework. Most of these are community projects. Some of them are built during things like hackathons, and you guys can definitely be a part of this and check it out for inspiration. In fact, one of Cartesi's main goals is actually to get more developers reaching out to them and experimenting with the technology. They have a team called the Dev Ad team, which is happy to talk to any of you on one-on-one calls, brainstorm ideas, give you some inspiration, etc. And that team is also offering up to $5,000 to build decentralized apps with Cartesi, development tools, etc. So if you're interested at all in building something, definitely reach out to their team. You can also submit any existing project that you've built, and it's possible you'll be eligible for some grants money, or at least to get some mentorship and other opportunities. Now what I want to do is go through the deployment steps. So what we'll be doing here is deploying to a test network. So obviously you don't need to have any Ethereum, you don't need to have any money to be able to do this, but there are a few steps that we're going to go through. So first thing here is we're going to open up our project in Visual Studio Code or whatever code editor you want to use. Now there's a few files that we're going to modify just to specify the name of our decentralized app. So when we go through the deployment process, we know what it is. So first of all, we're going to go to docker bake.override HCL. Now I've already changed this, but for you guys, you'll see that we have things like target server, console machine, and you'll have DApp, then you'll have a name here, and then kind of the tag server, tag console, etc. Now, in your case, you're probably going to have something like Echo Python here. What you want to change this to instead is rock, paper, scissors, or whatever name you want to give this decentralized app. So just make sure in your Docker bake that after DApp, you have a name that you're going to remember. So actually just copy it, rock, paper, scissors. Now change that in all of these places. Now we're also going to go to the Docker compose file, and the same thing here, where we have our server manager, we're going to make sure that we change the name so that rather than Echo Python, it's rock, paper, scissors. Now don't delete the devil server, leave that. Just wherever you see the existing name like Echo Python, you're going to want to modify that. Now if we go in the Docker file, this should be fine. We don't need to change anything here. We can look in some of the other files, and I think that's all good. It's just this Docker bake and this Docker compose file that we're going to want to modify. So now that we've made those changes, the rest of the steps that we're going to follow are just going to be in our dev guide. So I'm going to open up the dev guide here on the left-hand side of my screen. I'll open up WSL on the right-hand side, and we can start going through some of these commands. Now I'm just going to follow this step by step, so please open this up on your computer as well so you have all of the commands to copy and paste. First thing we're going to do is we're going to sign up to Alchemy, which will allow us to have some URLs for our application and to actually get some testnet Ethereum. Now we're going to use the Sepolia test network. So Ethereum, Sepolia testnet, that's just the one we'll do for this tutorial, but there's a few others that you can use, like Arbitrum, Optimism, Polygon, etc. We're just going to use Sepolium for here. So let's go over to Alchemy. Actually, let me just open that in a new tab. So we're going to scroll all the way down here until we get to the deployment instructions. Okay, deployment. I'm just going to right click and open a new tab so we still have that available. Now I already have an account, so I'm just signed into it. But what you'll do is make a new Alchemy account, and then we're going to make a new app. So I've already got an app created here, but I can go ahead and make a new one. So create new app, and we're going to give this a name. Now I'll just call this rock, paper, Cartesi like that. I don't need to give it a description, that's fine. And for the network, we're going to change this to Ethereum Sepolia. Okay, so just make sure you have an app, name it whatever you want, make sure the chain's Ethereum, and the network is Ethereum Sepolia. Okay, so now this has been created. We'll just leave this page open because we're going to use this later on. Now what we need to do is we need to get some Sepolia testnet Ethereum so we're able to actually deploy our app because we need a little bit of Ethereum to pay the gas fees on the test network. Don't worry, this is completely free. So what we'll do is go to the Sepolia faucet. So again, I'm going to open this link in a new tab here, and we need to sign in with Alchemy. So we're going to click Alchemy login. We're going to sign in. It should just automatically sign you in if you were signed in with the other tab. And we're going to open up MetaMask. Now for MetaMask, we got to type in our password. So let me do that first. And we're going to go to any account that we want. So in this case, I'll just go to account number 1. I already have some ETH on here, but that's fine. What we'll do is we'll copy to clipboard the address, and we'll make sure that we're on the Sepolia network. So if we go to networks, we should have the test networks down here. If you don't see them, you can toggle this button and click on Sepolia. Again, you're going to copy the address of whatever account it is that you want to use. We'll have to eventually have some ETH on 2 accounts, but I'll show you how to do that in a second. And we'll paste our wallet address. We'll do the CAPTCHA, and we'll just say, send me ETH. So it should send us some Ethereum. Might take a minute or two to go through, but it should kind of pop up the transaction here and just give us some of this testnet ETH. All right, so now I have sufficient Ethereum because I've used that faucet. And what I can do is actually start building my application for deployment mode. So what we're gonna do is copy this command right here. And we're gonna go into our terminal. Again, if we're on Windows, we're gonna use WSL. And we're gonna change into the directory where our application is. So in this case, it's gonna be CD rock, paper, scissors. Okay, so I'm inside of the Rollups examples, rock, paper, scissors, and I'm gonna paste this command. And I'm going to make sure the Docker desktop is running. All right, so my Docker desktop is running, and we're going to go to where it says network here, and we're just going to change this to say Sepolia. Now make sure it's Sepolia, not Sepoli. This is actually just a small typo that should be resolved in the version that you have, but for me, we'll just put Sepolia, okay? So we're going to go ahead and hit enter, and it should build everything that we need. Once that's done, I'll be right back. Keep in mind, this can take a minute or two. There's quite a few things it does need to build. So the build phase is now finished, and we are ready to actually deploy the on-chain components for our Cartesi DApp. Now, what we'll be deploying is something known as the Cartesi DApp Factory, which will be the on-chain part of our whole decentralized app. Later, we'll then actually run a node, and the node will be what's sitting off-chain, communicating on-chain, and kind of logging the results of the rollups. Anyways, to be able to perform this deployment, we need to actually export a few variables. So the first thing we're going to need to get access to is our 12-word mnemonic. I don't know if that's how you pronounce it, but essentially the 12-word secret key that gives us access to our MetaMask wallet. Now, it's very important for this next step that you are alone and that you're not sharing this information with anybody. Even in my case, it's a bit risky to be recording this because you guys can access my wallet. Fortunately, I don't have any funds here, so even if I were to leak something, it's okay. But as soon as you get access to this 12-word mnemonic here, you want to make sure no one's looking at your computer. You don't store this anywhere insecure because this will give access to your entire MetaMask wallet, but we do need this for the deployment phase. So if you already know where that is, great. If you don't, I'll show you how to retrieve it from MetaMask. So if you open up MetaMask here and you go to the 3 dots and you click on settings, you can go to security and privacy. And what we want to do is reveal our secret recovery phrase. Now it's going to ask you a few questions and it's going to say, for example, if you lose your secret recovery phrase, MetaMask cannot help you. Okay. If someone is asking for this phase, you're being scammed, sorry. So we'll go here and then we'll click continue. Okay, so now we need to enter our password and make sure no one is looking. I will hide this part here, but once you enter the password, it will give you that kind of 12-word key. And then we're going to use that in our terminal in a second, so make sure you copy it. All right, so I have my 12-word mnemonic. Now what we're going to do is export a variable here in our terminal. So I'm going to go to clear, and I'm going to type export, and then in capitals, this is going to be MNEMONIC, mnemonic is equal to, and inside of double quotation marks, we are going to paste our kind of secret recovery phrase, which should be those 12 words. So paste them inside of here, then hit enter. I'm going to do that, then clear my terminal so you guys don't see them. But make sure that you do this in the instance of the terminal where you're going to be running the following commands. If you were to stop the terminal and restart it, you would actually need to repeat this step again because this variable only exists in the current instance of this terminal. Again, meaning as soon as you close the terminal or you're using a different terminal, you would need to repeat this step. Okay, let me go ahead and do that. I'll be right back. All right, so my 12-word phrase is now exported as the variable here, which gives us access to MetaMask. Keep in mind, by default, this will use the first account that you have in MetaMask when it does the deployment. Now, the next thing we need is not something that's secret, and this is going to be the Sepolia RPC URL. So what we're going to do is go over to Alchemy. We're going to click on API key here. Obviously, don't leak your API key, but for the URL we need, just this HTTPS URL. It's fine if this is leaked, so we're going to copy that here. We're going to go back to our guide, and we're going to type export, and then RPC underscore URL, and this will be equal to, and we can simply paste the URL here. Okay, so now we have the URL and we have the mnemonic. Now what we're going to do is actually deploy this to the target network. So we're going to copy this command right here. Okay, we're just going to fix any of the potential line breaks. Sometimes you can copy in a new line character, so that's why I fixed that right there. I'm going to go to env, And I'm going to change this to .sepolia. So where we see network, we need to replace that with the network name, which is Sepolia. And for the DApp name, this is going to be the name that we changed in the very first step of the video, where we were in those kind of Docker files, and we changed it from EchoPython to rock, paper, scissors. So we'll say rock, paper, scissors like that. Just to clarify, again, if we go to VS Code, it's what you have here that we changed in the Docker bake and the Docker compose override, okay? That's the DApp name. So let's go back, open up our guide, and we're going to go ahead and hit enter. Now, what this should do is spin up the necessary, volumes, containers, etc., and then actually deploy this to the test network that we're using. So give this a second to run. Once it's finished, I'll be back. All right, so the deployment is finished. You can see some logging information here. And now that this is done, what we're going to do is tear down the components and the volumes that we no longer need. And we're going to do that by copying the command that is in the next step of our dev guide. So we're going to copy this in here. Again, we're going to fix our line breaks, and we're going to replace wherever it says network with the test network we're using, which in this case is Sepolia, and the DApp name with the DApp we deployed, which is rock, paper, scissors, like that. Okay, so go ahead and hit enter. It's going to remove all of those containers and volumes that we no longer need. Now we can go ahead and press clear. Now at this point, we've kind of done the on-chain component where we've deployed this Cartesi DApp factory, which essentially creates the DApp on-chain for us. What we'll need to do next is run node. Now, this is just like running a regular Ethereum node. In this case, we're running it on layer 2, but this node will actually run the backend for us and allow us to inspect the state and see information about our app. So this is also one of the advantages of Cartesi, is that we can create our own infrastructure and run our own nodes. And anybody that's interested in the state of our application can either use an existing node that maybe we expose to the internet, or they can just run their own node and they can process all of the inputs that have gone through, and the state of the Cartesi machine will be at whatever the current state of it is on the network. I'm hoping that makes a bit of sense, but in order to actually use the application, you need to have a running node. It relies on these nodes that are on layer 2. It's kind of the whole part of the framework. Anyways, what we can do now is we can have a look at what the address of our deployed contract is by using this cat command, or we can just go and do it from VS Code. So if we go to VS Code here, we can go into the deployments folder, and you should see that we have a folder for Sepolia. So if we click here, you can see we have rollups.json and we have rock, paper, scissors, and this gives us the address of our DApp. So this is something we'll use later on, but just keep in mind that we have that information inside of Sepolia. Okay, now that we have that, let's go back and run the node, and then I'll show you how we interact with it from the front end. So next thing we need to do here in the same terminal instance as before is we need to export the WSS URL, which is the WebSocket endpoint. So what we'll do is go to Alchemy, we'll go to API key again, and we'll copy the WSS URL. We're then going to go here and type export WSS. Okay, so WSS underscore URL. Let's make sure that's all in capitals. And this will be equal to, and we'll paste the URL in here. Okay, so now we have all the variables in this instance. We have the mnemonic, we have the RPC URL, and we have the WSS URL. Now what we'll do is we'll actually build a server manager for our target network and then run a validator node, which will just be happening on our local computer. Now I'll talk more about how these nodes work and how to run different instances later on, but what we want to do for now is simply build this. So we're going to copy this command, paste this in. Notice Sepolia is already inputted for us, for the network argument. So we're going to have docker buildx bake server load set the argument of network to Sepolia. So let's hit enter. Again, give that a second to run, and then I will be right back. Okay, so our build is now complete, and all we need to do is run this validator node. Now you'll notice there's two commands here. The one below for host mode is if you want to actually be debugging the application while you're running it, you can run it in host mode. We don't need to do that. We're just going to run this normal validator node. Now again, I am just going to fix some of the line breaks here, because when you copy in the command, sometimes you get those new line characters. I'm going to change the network to be Sepolia. And for the DApp name, same thing. We want this to be rock, paper, and scissors, or whatever you change the name to. Okay, so go ahead and run that. Going to take a second to spin up. And now we have a validator node, which is actually running our backend inside of the Cartesi machine. So at this point, our DApp is pretty much deployed. We have what we need on chain. and we have the backend validator node running. Now, again, you can run as many of these nodes as you want. And if you wanted this to be available to anyone, you would need to expose the port that this is running on to the internet. So it gets a little bit more complex in that instance, but pretty much we have a server running on port 5005, which gives us access to inspect the Cartesi machine, right? So if we go back to our front end, I'll kind of explain some things while this runs in the background. We have this default URL, right? This URL is what we're sending requests to get information about the state of the Cartesi machine. Now, in this instance, since we're running this validator node on our local computer, this is going to work completely fine, and we don't need to change anything because we're connected to our own node running on localhost. If we wanted to connect to a different node that wasn't running locally, then what we would need to do is put the public IP address of that node or whatever the domain is, and then 5005/inspect, right? So we would have to have some node that's exposing this port or exposing whatever port they want to forward it through. And we would have to connect to that node and then use the correct kind of address, right? /inspect. I'm hoping that makes a little bit of sense, but this is just like connecting to any other node on any blockchain network. If we want to be sending requests to it, well, we need to know the address of that and the port, etc. In our case, since we're running it on our local computer, we're fine. We don't need to change this. Now, what we do need to change in our front end is the address of our decentralized application and the input box address. Now, the DApp address we can find by going to deployments, Sepolia, and then rock, paper, scissors, right? So we'll just go and we'll copy the address here and we'll put that as our DApp address. This is going to change now because we're running this on a different network. So there you go. That's our DApp address. Next thing we need to do is find the input box address. Now, contracts like input box are part of the Rollups framework, which are deployed by Cartesi on the different test networks that are available, or on Ethereum mainnet, for example. In this case, we're working on Sepolia. So all of the different contracts that you need, like input box, are already on there and they've been deployed for you by Cartesi. You don't need to deploy a duplicate version of these. It's just one that works for all of your Cartesi dApps. So what we'll do is we'll just go to a URL that I'll leave in the description that shows you what all of the addresses of these contracts are. So this is in the description. We have all of the deployments for all of the rollups that are on chain. So we have mainnet, optimism, etc. We want Sepolia. Now here you can see all of the different contracts that exist that can be used for, again, kind of transferring assets, etc. We're going to go to input box because this is what we use to send inputs to our DApp. Now we're going to copy the address here. Don't worry, again, this will be linked in the description so you can find this exact page. And we're just going to change the input box address here to be that, okay? So now what we've done is we've modified the DApp address, we've modified the input box address, and that's it. We can now run our front end and interact with our on-chain DApp. So we're going to CD into rock, paper, scissors, CD into front end, and yarn start. Once that starts, I'll be right back and I'll show you how we interact with the DApp. Okay, so our front end is now running, and you can actually see that we're getting some logs here on the right-hand side of our screen that are showing that the inspect request that we're sending is actually working properly. You can see when I send the inspect request, we get received, finished status, received inspect request data, etc. It gives us the logs we had before when we were running this in development mode. So interacting with this node is working locally. Now what we want to do is make sure we can actually send inputs. Now remember, sending inputs requires the blockchain. So let's try to create a challenge and see how this works. So we go to create challenge. Okay, we're going to send a, transaction here. This will use the input box contract and send the transaction to the DApp address that we specified in our front end. And remember, we've changed that now so that that is the DApp address of our on-chain kind of Cartesi DApp, right? So that transaction has been sent, and I will note that it will take a little bit of time here, could take up to a few minutes for us to actually get this update in our front end. And the reason for that is that we had to use the blockchain. So we need to wait for a certain number of confirmations before this is actually going to pop up in our backend and be handled by the backend. So just be patient, wait a little bit, and then once our backend gets that advanced kind of request data here, when we update our challenges, we should see that updated challenge. So right now we're not seeing it. Again, we're just going to wait a few minutes. We'll get the request popping up in the backend, and then we'll be able to interact with it like we did before. So this input has now been handled by our backend. If I scroll up, you can see some logs related to it, like the payload, input, etc. And you can see here now that we have challenge 0, which is our active challenge, and we're just waiting on an opponent. So now what we should be able to do is change over to another account. Notice I have some test Ethereum here in this account as well because I set that up. And when we refresh the page, you see now that we have the ability to accept the challenge. So working exactly like before, I can change this to paper and click on accept challenge. And now, similar thing, we're just going to need to wait for all of the confirmations, and then the input will get sent to our backend, and then we should have the ability to reveal our moves. Once that's finished and the backend picks up this input, I'll be back and we'll kind of repeat, the reveal process and just make sure everything is working. All right, so the next input has been accepted here by the backend, and you can see now we have the same state we had when we were doing local development. The opponent has a move that's hidden. We have a move that's hidden. We can go ahead and reveal. So let's click on this and send the reveal transaction, and then we'll go do the same thing from the other account. So let's switch over here to our account number 1 and refresh and reveal the move. Okay, and now we'll wait for both those inputs to be handled, and we'll just make sure that everything's kind of working properly and that we see the log of the winner, which I believe should be the player who selected paper, which I think was account number 2. All right, so both those inputs have been processed now by the backend. And we can see that we are getting the log of the challenge saying the winner is the opponent. The opponent made the move paper and we made the move rock. Now, if we go back to our other account here and we give this a refresh, we should see that we get the opposite. We are the winner because we made the move paper and the opponent made the move rock. So everything is working. Our deployment is successful. Again, it's going to take longer on a real network when you need to process those transactions. So just be patient. I promise you things will pop up. We did everything properly, and you can see the deployment process was actually relatively straightforward. So that is pretty much it. Just to clarify what you would need to do if you want this front end to actually be working for anyone. First of all, you would need to deploy the front end. So you'd have some kind of URL and just deploy this using whatever you normally would. You could use Vercel or something. You need to have some kind of node. This node would need to expose the port for the inspect server. And then you just need to have the front end communicate with this node or any node that you want to be able to get information about the Cartesi machine. Once you do that, everything should just be working, and you'd have a fully decentralized application that anyone with a MetaMask account or really any blockchain network account would be able to access and use. So now as we wrap things up, I will quickly show you another tool that you might find useful if you start working with Cartesi more and doing some more deployments, building, etc. Now, this tool is called Sunodo. I'm not sure actually how you pronounce this. I'll leave the link in the description, but this is a framework for developing decentralized applications built on top of Cartesi technology. It helps developers to create, build, run, test, deploy, monitor, and doctor or verify their application. So a lot of the complex commands that we just went through using Docker, etc., we wouldn't need to actually type in if we're using this Sunodo package. So this just, again, kind of wraps and abstracts some of the things that we went through and created manually and gives you a kind of better API and experience for actually working with and developing Cartesi dApps. So with that said, that will wrap up this video. In the next videos in this series, we'll go more in depth to the Cartesi lifecycle and architecture, and we'll talk about some next steps and things you might want to consider as you continue to get better at Web3 development and working with technologies like Cartesi. I hope you enjoyed this video, and I look forward to seeing you in the next one.